Happy morning children. Today we are going to study Mathematics Class 6 Chapter 2. The name of the chapter is Whole Numbers. Whole Numbers. You are familiar with the different types of numbers such as natural numbers, even numbers, odd numbers, fractions, decimals, etc. Then what do you mean by natural number? Yes, as we know, the numbers 1, 2, 3, etc. we use for counting. That numbers are known as natural numbers. They come naturally when we start counting. Hence, mathematicians call them as natural numbers. Natural numbers. The numbers 1, 2, 3, 4, etc. which we use for counting are known as natural numbers. The numbers 1, 2, 3, 4, etc. which we use for counting are known as natural numbers. Hence, natural numbers start with the number 1. It is represented by, the collection of natural numbers is represented by capital N. N is equal to set of 1, 2, 3, 4, etc. Then, 1 is the smallest natural numbers. Natural numbers start with 1. So, 1 is the smallest natural number. Next topic, successor and predecessor. Successor and predecessor. The number that comes just after a number is known as successor. The number that comes just after a number is known as successor. Then what about predecessor? The number that comes just before a number is known as predecessor. The number that comes just before a number is known as predecessor. Consider the example. Predecessor, actual number, successor. Consider the first number 16. What is the successor of 16? 16 plus 1. That is 17. Successor of 16 is 17. Then what about predecessor? 16 minus 1. That is 15. Predecessor of 16 is 15. Then consider the next number 295. What is the successor? Number that comes just after 295. That is 296. Then what about predecessor? Number that comes just before 295. That is 294. Then third number 4531. 4531. What is the successor? 4532. What about predecessor? 4530. If you add 1 to a natural number, you get its successor. If you subtract 1 from a natural number, you get its predecessor. If you add 1 to a natural number, you get its successor. And if you subtract 1 from a natural number, you get its predecessor. Every natural number has a successor. Second point, every natural number has a successor. We know that n is equal to 1, 2, 3, 4, 5, etc. are natural number. Every natural number has a successor. Then every natural number except 1 has a predecessor. We know that natural numbers start with the number 1. So, natural number 1 has no predecessor. Every natural number except 1 has a predecessor. Except 1, all other numbers has a predecessor. Next one, whole numbers. Whole numbers. The natural numbers along with the 0 form the collection of whole numbers. The natural numbers along with the 0 form the collection of whole numbers. Hence, 0, 1, 2, 3, 4, etc. are whole numbers. We know that 1, 2, 3, 4, etc. are natural numbers. If 0 also there, if 0 is also there in that collection, then it is known as whole numbers, the collection of whole numbers. Then we can represent it as W equal to set of 0, 1, 2, 3, 4, etc. W equal to 0, 1, 2, 3, 4, etc. Then what is the difference between natural numbers and whole numbers? Natural numbers start with the 1 and whole numbers start with the 0. 0 is the smallest whole number. 0 is the smallest whole number. We know that whole numbers start with a 0. So 0 is the smallest whole number. Second point, all natural numbers are whole numbers, but all whole numbers are not natural numbers. All natural numbers are whole numbers, but all whole numbers are not natural numbers. We know that natural numbers n is equal to 1, 2, 3, 4, etc. These natural numbers are whole numbers, but whole numbers start with the 0. 0, 1, 2, 3, 4, etc. So, whole numbers are not all whole numbers. All whole numbers are not natural numbers. Why 0 is there? 0 is not in this group. So, 0 is not a natural number. So, all whole numbers are not natural numbers. Next point, every whole number has a successor. Every whole number has a successor. You can see here, every whole number has a successor. Every whole number except 0 has a predecessor. Every whole number except 0 has a predecessor. Whole numbers start with 0, so it has no predecessor. Whole number 0 has no predecessor. Every whole number except 0 has a predecessor. Next topic is number line. Number line means a line of numbers. Now we are going to study how to construct a number line for whole numbers. First you have to draw a line. Then mark a point here. Label it as 0. First you have to draw a line, mark a point on it, label it as 0. Then mark a second point and label it as 1. The distance between these 2 points, that means the distance between 0 and 1 is called unit distance. Distance between 0 and 1 is called unit distance. Then mark the points 2, 3, 4, 5, 6, etc. in unit distance or in equal intervals. One more time, how to construct a number line. First you have to draw a line, mark a point on it, label it as 0. Then mark a second point to the right of 0, label it as 1. Then the distance between 0 and 1 is called unit distance. Then mark the points 2, 3, 4, 5, 6 and so on, etc. at a unit distance or in equal intervals. Thus, we got a number line for the whole numbers. So, here we have a number line with whole numbers represented on it. Here, consider the points 2 and 4. 2 and 4. What is the distance between the points 2 and 4? Certainly it is 2 units. Here to here 1 unit, here to here 1 unit. 1 plus 1, 2 units. Then what about the points 2 and 6? Here to here 1 unit, here to here 1 more unit, then here to here 1 unit, here to here 1 unit. So, the distance between the points 2 and 6 is 4 units. Distance between the points 2 and 6 is 4 units. Also, every number on the number line has its successor on the right side and predecessor on the left side. Now, consider the number 4 and 7. 4 and 7. We can see that the number 7 is on the right of 4. The number 7 is on the right of 4 and 7 is greater than 4. Now consider the number 6 and 8. 8 also lies in the right side of 6 and 8 is greater than 6. So, out of any two numbers on the number line, the number on the right of the other number is the greater number and the whole number on the left is the smaller number. Out of any two numbers on the number line, the number on the right of the other number is the greater number and the whole number on the left is the smaller number. Example, 4 less than 9. 4 less than 9. So, 4 is on the left of 9. 12 greater than 5. 12 is greater than 5. 12 is on the right of 5. We can easily perform number operations such as addition, subtraction and multiplication on a number line. Now, we are going to study addition on the number line. Addition on the number line. Let us see the addition of 3 and 4. 3 plus 4. Start from 3. Start from 3. Since we have to add 4 to 3, make 4 jumps right. Make 4 jumps right. That means 3 to 4, 4 to 5, 5 to 6 and 6 to 7. Make 4 jumps to the right. Now we reach at 7. So 3 plus 4 is equal to 7. If you have to add two numbers, make jumps to the right side. So 3 plus, here we got 3 plus 4 equal to 7 using the number line. Next one, subtraction on the number line. Subtraction on the number line. Let us see the subtraction. 7 minus 5. 7 minus 5 is the question. Since 5 is being subtracted, we have to start from here. We have to start from 7. Since 5 is being subtracted, move towards left. Since 5 is being subtracted, move towards left with one jump of 1 unit. Make such a 5 jumps. Here 1, 2, 3, 4, 5. So now we reach the point 2. So 7 minus 5 is 2. This way we can subtract numbers using a number line. Next one, multiplication on the number line. Multiplication on the number line. We know that multiplication is repeated addition. So here also we have to move towards right. Multiplication is repeated addition. So here also we have to move towards right. 3 into 4. 3 into 4. For multiplication, here we have to start with the 0. Here we have to start with the 0. Then make 4 jumps and each jump, one jump consists of 3 units. one jump consists of 3 units. That means 1, 2, 3. Make such 4 jumps. So 0 to here 3. Then next one 3 to 6 and 6 to 9, 9 to 12. So we reach at 12. So 3 4s are 12. So the answer is 12. We got answer from the number line as 12. One more time. Multiplication on the number line means, here one example, 3 into 4. That means we have to make 4 jumps and each jump consists of 3 units. Each jump consists of 3 units. That means move 3 units at a time. Move 3 units at a time. One jump consists of 1, 2, 3. One jump consists of 3 units. Make such 4 jumps. Then you will reach at 12 and we got 3 4s are 12. Next one, properties of whole numbers. Properties of whole numbers. Some numbers and there, some are given here. First one, 5 plus 2 equal to 7, 3 plus 3 equal to 6, 0 plus 15 equal to 15. First one, 5 plus 2 is equal to 7. We know that 5 is a whole number, 2 is a whole number. The answer 7 also a whole number. Then what about the second one? 3 is a whole number. Then this is also 3. Then next answer 6. The sum, that also a whole number. Here 0. 0 is a whole number. 15 is a whole number. The answer 15 also a whole number. The sum of 2 whole numbers gives a whole number. That means adding 2 whole numbers, the result also a whole number. That is, collection of whole numbers are closed under addition. We can say collection of whole numbers are closed under addition. Since the sum of 2 whole numbers gives a whole number, we say collection of whole numbers are closed under addition. Now let us consider the multiplication of whole numbers. 7 8s are 56. 7 into 8 equal to 56. 5 5s are 25. 0 into 6 equal to 0. We know that 7 is a whole number, 8 is a whole number. The answer 56 also a whole number. Then what about next one? 5. 5 is a whole number. The answer 25 also a whole number. Then this one, 0 is a whole number, 6 is a whole number. The product 0 also a whole number. The product of 2 whole numbers gives a whole number. The product of 2 whole numbers gives a whole number. That is, collection of whole numbers are closed under multiplication. Then we can say the product of 2 whole numbers gives a whole number. So we can say the collection of whole numbers are closed under multiplication. Next one is closure property. We know that whole numbers are closed under addition and multiplication. Whole numbers are closed under addition and multiplication. This property is known as closure property. This property is known as closure property. And it is not possible for subtraction and division. That means whole numbers are not closed under subtraction and division. Let us verify it. For subtraction, consider the number 6 minus 2 equal to 4. 6 is a whole number, 2 is a whole number. The answer 4 also a whole number. But what about this one? 7 minus 8. 7 is a whole number, 8 is a whole number, then what is the answer? The answer will be a negative number. About negative numbers you will study in higher classes. 7 minus 8 is not a whole number. So, whole numbers are not closed under subtraction. Consider division. 8 divided by 4 equal to 2. We know that 8 is a whole number, 4 is a whole number. The answer 2 is also a whole number. But what about this one? 5 divided by 7. 5 divided by 7 is equal to 5 by 7, and it is also not a whole number. It is also not a whole number. It is not a whole number. So, whole numbers are not closed under subtraction and division. Whole numbers are not closed under subtraction and division. Next topic, division by 0. Division by 0. Division of a whole number by 0 is not defined. Division of a whole number by 0 is not defined. Example, 2 divided by 0 is equal to not defined. 5 divided by 0 not defined. 32 divided by 0 not defined. Then, but 0 divided by 2 is 0. 0 divided by 2 is 0. 0 divided by 5 is 0. 0 divided by 32 also 0. Division of a whole number by 0 not defined. Next one, commutativity of addition and multiplication. Commutativity of addition and multiplication. First we can consider addition. Consider the examples. 3 plus 2 is equal to 5. 2 plus 3 is also equal to 5. What is the difference here? Here 3 plus 2, here 2 plus 3. Numbers are same, but the order is changed. Whole numbers are same, but the order is changed. Here 3 plus 2, here 2 plus 3. But the answer is same in both cases. Is it? Here also 5, here also 5. So, we can write, hence 3 plus 2 is equal to 2 plus 3. 3 plus 2 is equal to 2 plus 3. Consider the second example. 4 plus 6 equal to 10. 4 plus 6 equal to 10. Then here 6 plus 4 equal to 10. Here also numbers are same, but the order is changed. Here 4 plus 6, here 6 plus 4. But in both cases, answer is same. The sum is same. So, we can say in addition of whole numbers, even the order of numbers changed, the answer will be same. We can say, hence here we got 4 plus 6 is equal to 6 plus 4. We can add two whole numbers in any order. We can add two whole numbers in any order. Addition is commutative for whole numbers. We can add two whole numbers in any order. Then we can say addition is commutative for whole numbers. This property is known as commutativity for addition. This property of whole numbers is known as commutativity for addition or commutativity of whole numbers. Generally we can represent it as A plus B is equal to B plus A. Suppose A and B are two whole numbers. Then A plus B will be same as B plus A. Here, suppose here A is this one, B is this one. A plus B. Here, A plus B is equal to B plus A. So, generally we can write A plus B is equal to B plus A, where A and B are any two whole numbers.